Hello everyone, welcome to a new video. Today we're going to look into Mutual TLS with Identity Server 7. So why Mutual TLS is important, right? Let me quickly show you. So I'm in the Identity Server console. I'm going to create a standard based application. I'm going to name this FAPI enabled and I'm going to tick FAPI compliant application. Alright, so application is created. Now if you come down to client authentication, whenever your client application is financial grade API security compliant, the only authentication methods that are supported is mutual TLS and private key JWT. We already covered private key JWT in a separate video, so please go and watch that if you want to learn how to do the private key JWT setup. Today we're going to look into mutual TLS. So we can confirm the same if you go to FAPI documentation. So under confidential client section, it has stated that if your application is FAPI compliant, it should support either mutual TLS or private key JWT. So this shows the importance of learning about mutual TLS with the FAPI compliancy that Identity Server provides. Now let's look into the history of mutual TLS. So when it comes to history of mutual TLS based client authentication, we need to go way back into 2012. So in 2012, we got Auth 2.0 specification, and under the specification, under client authentication, we got kind of a hint that we can use a public private key pair to authenticate our client with the authorization server. But there's no mention of the word mTLS or mutual TLS. It's just a hint that you can use a public private key pair for authenticating your client. So in 2020, 8 years after the release of Auth 2.0 specification, we got a separate specification for mutual TLS. So it's called Mutual TLS Client Authentication and Certificate Bound Access Tokens. So this was released in 2020, and in this specification it clearly mentions that it is an extension to the section 2.3 of Auth 2.0 spec. So it is using a X.509 client certificate as client credential to authenticate our client against the authorization server. Then we come to financial grade API security specification. So this was released in 2021, and under financial grade API security, they used the mutual TLS specification which we shown previously. So now we see the bigger picture, right? So under financial grade API security, they have used mutual TLS spec which was released in 2020 as part of their confidential client authentication mechanisms. So this is how everything linked together. Alright, so now let's get into the demo. So before we begin with the mutual TLS demo, we need to add this configuration into the deployment.toml file. So you need to add this auth mutual TLS and the client certificate header type. After you do this, you need to restart the identity server as well. I have already done this, so I'm going to log into the Identity Server console now. So let me enter the username and password. Alright, so we are logged in. I have already created a standard based application in my Identity Server to demonstrate mutual TLS. So let's log into this. Alright, so I have allowed code grant type, and I have set up the authorized redirect URL, and under client authentication I have selected mutual TLS as my client authentication method, and under certificate I have imported my public certificate here. So we did this certificate generation in our private key JWT video. Also we created this client application from the ground up in that video as well. So please go and watch that video if you want to know how to do this setup. Alright, so we are all set. Now we just have to try Mutual TLS. So I'm going to use Postman for this. So we are going to call the token endpoint using Mutual TLS. So in order to call this token endpoint, first we need to provide our grant type, which is going to be client credentials, and the client ID. So why we need to pass client ID? Because we are not using any authorization mechanism when using Mutual TLS. So in order to identify where this request is coming from to the authorization server, we need to provide the client ID here. And so let's just hit send. Alright, so we are getting 401 unauthorized. So this is because I haven't set up the client certificate in my Postman environment. So first we need to do that setup in order to do our Mutual TLS handshake. So currently it's unable to do this, that's why it's failing. So let's do that as well. I'm going to add a certificate here. So CRT file, we need to provide the public key here, and the key file is the private key. So I'm going to import the private key here as well. And the host is localhost and port is 9443. Paraphrase is going to be WSO2 carbon. So it's my key store password. So once we have this, now let's try it out. So I'm going to hit send. Alright, so now we are receiving an access token. So what happened was, when we add these certificates, so now Postman is able to do the Mutual TLS handshake with the identity server using the public key and the private key that we provided. So alright, so this is good. So now I'm going to remove this. So I'm going to certificates and I'm going to remove this. So now it's not working, right? But so I'm going to go to headers. I'm going to add this XWSO2 Mutual TLS certificate header here, and I have added the public key value here as the value. So I have copied this from the certificate and I have added it here. Now let's see what happens. So it's taking some time. Okay, so we are receiving an access token, right? So but are we doing a Mutual TLS handshake here? Because we are just sending the public key certificate in the header, right? So what's happening here? Now to understand this, let's dig into the next section of the video. So let's see why our identity server returned us the access token when we just pass the public key in a header. So this is because in a real world use case, we won't be exposing our identity server to the client directly. So you would normally have a load balancer in the middle. So this load balancer is the one who's responsible to validate the public key and the private key and do the Mutual TLS handshake with the client. So once this handshake is done, when the request comes, this load balancer, so we can do an implementation like this. We can take the public key from this request and then do a header injection with the public key to our request. So why we do this? Because our identity server needs to validate whether this client ID is associated with the correct public key in this request. So once this validation is done by the identity server, then it can send back the token response. Hope you guys are clear on the idea behind why this worked with the header injection with the public key. And if you guys have any questions, please leave a comment in the comment section. We will get back to you guys. So that's it for this video. Thank you for watching.